In today's lecture, we discuss the design of biological unit process for the sludge digester. It is anaerobic suspended growth processes, right? So basically, here on screen you can see that the picture of the sludge digester, suspended growth or sludge digester are there. So in the wastewater treatment plant, the primary and secondary processes are provided. So from the bottom hopper of the primary and the secondary tank, the sludge is transported to the sludge digester, right? So the function of this sludge digester is to convert the solid of the sludge into the simple bio non-degradable solid under the anaerobic condition. So at the sludge digester deal with the primary and the secondary sludge, it is also called as a sludge treatment unit, right? And the bacteria which carry the degradation first and from the intermediate product of volatile acid and then methane forming bacteria which is convert acid into the carbon dioxide and the methane, right? So the low molecular weight fatty acid are the intermediate product of anaerobic biodegradation, and this acid are known as a volatile acid, right? Because they can be distilled atmospheric pressure. Okay, now here on screen you can see that the picture of the sludge digester are there, right? Here this is a sludge digester, and this in this portion, in this hopper, the sludge which is collected, right? Okay, now the next one, which is the difference between the primary sludge and the secondary sludge. Okay, what do you mean by primary and the secondary sludge? So in the primary sludge, the moisture content which is 95%, and the secondary sludge in the here in secondary sludge in ASP, it means that activated sludge process, it is 90%, 99%, and in trickling filter it is 95 to 98%, right? Now it is a high putrescible and it is a not highly putrescible. Then quantity which is 20 meter cube per million liter of wastewater, and the quantity which is 5 meter cube per ml of the wastewater with the trickling filter, and the ASP which is 35 to 50 meter cube per million. Okay, the next one, which is the volatile solid, which is 70%, and the secondary sludge which is range which is 45 to 70%, right? Okay, the operation efficiency of sludge digestion, which is here in the sludge digestion, the pH should be between maintain 6.7 to 7.5, right? Then alkalinity, which is 1000 to 5000 mg per liter of the CaCO3, calcium carbonate. Then volatile acid, the range which is less than or equal to 50 mg per liter. Now the next one, which is the nitrogen and the phosphorus availability, which is necessary. Then recycling of digested sludge improve efficiency. This is the operational efficiency of the sludge digester. Now we discuss the design criteria of the sludge digester, right? So the first one, which is the volatile solid loading, which is 0.5 to 1, range which is given 0.5 to 1 kg per meter cube per day. Now the next one, which is detention time, which is 20 to 60 days. Then digester volume, which is V is equals to, in bracket, Vf minus 2/3 bracket Vf minus Vd bracket complete into the T, where Vf which is equals to volume of the fresh sewage sludge, then Vd which is equals to volume of the digested sludge, T is equals to digestion time in the days. So this is the basic design criteria of the sludge digester. Now the next one, which is the design steps. Okay, so here on screen various steps for the sludge digester are given. The first of all, step 1, which is assume 65% of solid remove in PST, primary settling tank, right? So the remaining, which is 35%. Okay. Now assume the moisture content of the flash sludge, which is 95%. Then assume 5 kg of dry sludge make 100 kg of wet sludge. Then step 4, which is find density of the sludge. Step 5, which is find volume of the fresh sludge. Then step 6, which is find volume of the digested sludge. Then step 7, which is assume retention period, which is 30 days. Then step 8, which is find volume of the digester. And step 9, which is provide a 6-meter depth. Then step 10, which is find the area. And the last one, which is step 11. And lastly, we find the diameter. Okay, here on screen you can see that the numerical are given for the sludge digester. The first of all, the data which is design a sludge digester with the following data. Okay, so here in the data, the given value which is average sewage flow, which is 50 into 10 raised to 6 liter per day. Then total suspended solid which is given 300 mg per liter. Then moisture content of the digested sludge which is 85%. And assume other necessary data. Right. Okay, first of all, we find a mass of the suspended solid in the wastewater generated, right? So here you can see that the total suspended solid are given and the average sewage flow are given, right? So from this data, we can find out the mass of the suspended solid in the wastewater, right? So this is the value which is given in mg per liter. So here we converted into the kg per day. So the final answer for the mass of suspended solid in wastewater generated, which is 15,000 kg per day. Right. Now the second step, which is assuming 65% of solid removed in the PSD, it means primary settling tank. Right. Now the mass of solid removed in the primary settling tank, which is 0.65 into the 15,000, right? Because the 15,000, here we find the value of mass of suspended solid in wastewater generated, we find which is 15,000. So here which is the value which is 15,000. So the answer which is 9,750 kg per day, which is mass of solid removed in the primary settling tank, right? Now we assume a 5 kg of dry sludge which make 100 kg of the wet sludge, right? So the 975 kg of dry sludge will make how much sludge? So for that, which is 1000 into 9750 divided by 5. So the answer which is the 1,95,000 kg of wet sludge per day. Okay. Assume G is equals to 1.02. So G is equals to rho sludge divided by rho water. So the G is equals to 1.02 given, right? And the water which is given 100,000. So the rho sludge which is equals to 1020 kg per meter cube. Now we find a volume of rho sludge which is produces. It means that VF is equals to mass upon density. Volume is equals to mass upon density, we know that, right? So the mass which is 1,95,000, we already find out that. Then the density which is 1020. So the volume which is the volume of rho sludge which is produced, which is 191.17 meter cube per day. Okay, the next one, which is the volume of digester sludge at 85% of moisture content, and the moisture of sludge which is 95%, right? So the VD is equals to VF in bracket 100 minus P1 divided by 100 minus P2. So here we have a value of VD. So the VD which is, we have a value of VF. So the VF which is equals to 191.17, we already find out that. Now P1 which is equals to 95 and the P2 which is equals to 85%. So here we put the value of P1 and P2. So the final answer which is 63.72 meter cube per day. Right. Now assume retention time which is 30 days. So the capacity of tank V is equals to, from this equation we find out capacity of tank. So VF minus 2/3 VF minus VD into detention time. So the VF which is equals to given 191.17 Then VF is also given, which is VD is also given, which is 63.72, and the detention time we assume 30 days, right? So the final answer, which is 3186.1 meter cube. So the capacity of tank, which is 3186.1 meter cube. Now they provide a 6 meter depth for the cylindrical tank. So the area is equals to V by D. So we find out V, which is equals to 3186.1 divided by depth, which is equals to 6. We provide a 6 meter depth. Area is equals to 531.0 meter square. Right. Okay. So from area we find out the diameter. From the area we find out the diameter. So D is equals to, for the diameter, for circular tank, the area is equals to A is equals to pi by 4 D square. We put the value of the area, which is 531.0 meter square, and from this we find out the diameter. So D is equals to 26 meter. So they provide a sludge digester with diameter, which is 26 meter, and the depth, which is equals to 6 meter, right? So this is the whole design of this sludge digester, right? I hope you all understood about the various biological unit processes design, right? The trickling filter, then the sludge digester, and the last one, which is the activated sludge plant, right? I hope you all understood about the today's lecture. Thank you for the watching. Thank you.